let's work on the leetcode problem 1096. This is called brace expansion. I think this is a very hard problem. It's hard to think and hard to implement if you first time face this problem. But I suggest that we can use this problem as a template. Then we remember the implementation, and actually there are a lot of problems that are similar to this one. So we can use this as a template to solve others. Let's see what this problem is about. So we are given an expression. It's called our expression, and it has a set of words. And this problem defines several kinds of operation. The first one is union. Actually, if you have this one, if it has multiple characters, then we can just union them. And for example, if A and B and union, we call that plus, and B and C, then the result will be A, B, C, right? We call this union operation, union or add. And also we have a multiplication. It's defined as this way. So A, B, and if it's multiplied by C, D, then it is A, C, A, D, B, C, and B, D. Okay? And remember that this expression can be done recursively. So which means we can have another expression like this. Okay, so we have some examples. So the requirement is to output all the words that given by this expression, and we need to sort the word according alphabetically order. And here is an example. We can work on this example together. Then A, B, C, D, E. Okay. Then we first see this part, right? This is just A, B, and C, D, E, right? Then this will become A, C, A, D, A, E, and B, C, B, D, and B, E. Then we just output the sorted version, which is equal to this output. Okay? And here's another example, and you can work on that yourself. So now this expression length is not so long, so we can use any way we want. Like we can do exhaustive search, or use the recursively search it to solve this problem. And we also define something here. We say we call this expression, for example, one expression is A and another expression is B. So no matter which expression we face, we can write it as this way: A plus B times something. For example, if we are going to have a C after we face B, then this will become if we need to add C into the previous results, then A becomes A plus B, right? And B becomes C. And the second option is this is for addition, and this is for multiplication. Multiply. then if it's multiplied, it's easier. So A goes to A, then B is replaced by B times C, right? So this formula will always be true. So we can keep this formula and remember what A and B is. Then at the end, we just add A and B to get the final answer. So now we will implement all the functions. We will use some unordered set to record A and B. Okay, so we will define several functions. For example, if we make it short, US, this equals to an ordered set string. Okay, USS. Then we define this function add, which is to add two representations, A and B. So in order to add it, we just need to put all the strings in B into A. Remember that we need to filter out all the empty strings. So we first define result, which should be equal to A. Then for string in B, if size is not 0, then we just add it into the result. Then we return res. This is add. Then we implement multiply. It's also similar. USS A, USS B. Then suppose the result is res. Then for every string in A and for every string in B, we just insert A plus B inside the result and return res. We can add one condition that if A plus B size is larger than 0, otherwise we won't do that. Okay, then we can recursively do the work. So we use a number k to remember where we are on this expression. And we put expression here so that we can access it very easily without using that as a parameter of the function. Okay. Then suppose the return value is USS, then the final value will be the vector form of USS. US begin, US end, right? Then we just sort it and return. So we're doing this step, right? We'll sort it after we get this value. Okay, then what we need to do is to implement this core function, DFS. It's a recursively search all the possibilities. USS, DFS. It takes no parameters, I think, because we put all those as a class variable. So the first thing is we can check if the current position, or what is the current position. Before we do the check, we need to have this A and B, right? We need to define those two for this DFS. So A and B. And initially, let's see what initial condition for A and B. A should be empty, right? How about B? If B is empty, then B times anything will become empty again. So what we can do is to make B have some member, but has a string. But this string itself is an empty string. So this is for B. And then we can do the actual work. So while k is less than expression size, and we require that expression k is not equal to the end of the curly braces. Then, first step is if the current position for k is a comma, what shall we do? We just k plus plus and continue, right? We don't need to do anything. Let's see if there, oh, okay, so it can only be a comma. There's no space between them, right? It's just separated by comma. So it says it only contain the curly braces, comma, and lowercase English letters. Okay, then the next one is to evaluate if this place is curly braces, right? In this case, what we need to do is to first we need to find out if we will do an add or if we need to do an add or a multiply, right? So we need to access k minus 1 position. Remember that k could be 0, so is add. We say if this is true, then if k is 0 or k minus 1, if it's a comma, then it's an add, right? If it's not a comma, then it's a multiply. And we don't care for the first position, so we just say keep it consistent with this condition. If it's comma, then it's and equals true. So we actually need false here. So if this is comma, then it's true. If not, we just it is and it will be false. Then remember with that we need to move k one step forward, because this place is curly braces. And then we need to calculate what's the coming expression, what's for this part. So that is C. We define C here. So USS C equals DFS. We do the recursively at here. Remember, we use K to keep track of where we are. So after we done, because where we will finish when we have met this end of curly braces. So when we are done, the k's position is at the curly braces, so we need to move one step forward. So k plus plus again. Then we will update a and b. So if is and is true, then what we will do, we will update based on this rule, right? So a will become a plus b, and b will become c. Otherwise, this condition is simpler, because if it's multiplied, a doesn't change, and b will become b multiplied by c. B and C. Okay, and I think we are done for this else. And another one is the last else is for lowercase English letters, A to Z, right? So actually this part has very similar code compared to this part, so we just copy it here and let's check. So if and, then this part can be kept the same, right? And so optimally we can put all those code together, might be, but we just keep it this way to make it simpler. Then for this condition, the item we are dealing here is actually not a curly braces, right? It's not a curly braces, but it's an English letter. So if it's an English letter, like it's like this. So we need to get the string here. So we will retrieve the string using k. So if k is, while k is less than the expression size, and this position is the lower sized English letter, so the lower case English letter, we will add this expression k into s. Remember, we need to increment k after we do the addition. Okay, now s is actually c here, right? So we just insert s into c. Then we do the following part. We don't need to increase k because there's no curly braces. So we delete this, delete this, delete this. Okay? Then we still update a and b the same way, right? So I think we are done here. So, and after that, we will need to return a and b. So let's try. Compile error. Auto string in b. Okay, this should be const. So this should be const as well. So I actually suggest we use const auto or auto here, so that there's less chance you will face this problem. And also because when you are doing this loop to get what is inside this unordered set or sometimes an unordered map, the data type inside this data structure is not the same one as you thought. So it's better to have an auto here. And this should be S1 and S2, right? So we have S1, S2. Okay, it seems correct. Let's submit the code. Yeah, it passed. And I think leetcode has some more functions. We can analyze the complexity. Okay, but it doesn't allow me to do that. Anyway, I think the code should be reorganized to make it seems better. So, for example, here, we actually have some repeated code. So what I can do is to make it look better, to do it this way. So no matter what we do, we'll need to judge whether it's add or multiply. So I can put the code here and put this part like this. So we don't need to decide again. This can be deleted. And I think for this part, we can do that together at the end, right? We can put it here. And we don't need this part, right? And we make the format better. So there's the end of the curly braces. And this looks better, right? Let's duplicate code. So we first decide whether it's an add. If so or not, no matter what, we decide what condition we are. This curly braces or not, just the only difference is how we compute C. If it's a curly braces, we just do another recursion. And if it's not, we will just get what is the string beginning from this location. And then we put this string into C. Then the way we update A and B are the same. So let's try. B and C. Okay, we can define C outside. Okay, this works. I think that's it. Thank you, and see you next time.